Okay. So this is a chapter 3 matrices, and matrix is a plural word, and singular is matrix. Singular is matrix, right? And in this chapter, we are learning this matrix which is represented in a tabular form, and it is a general way. We have to write M cross N is the order, mth row and nth column. These are M rows, these are N columns, right? And here in between, this is a general row, ith row. First row, second row, third row, and general row, ith row, and then comes the last row, that is nth row. Here also in columns, we have first column, second column, third column, and somewhere general column, jth column. And we have the last column, that is nth column. So this is how we write generally, and it is the expansion. First row, first column, first row, second column. This is second row, third column. This is third row, jth column. This is ith row, ith column, jth column. So this is our general element.
So इस J और N तो सेम ही हो गए.
J और N नहीं, J और N सेम नहीं. J हमारा जनरल कॉलम है और N इज द लास्ट कॉलम. N लास्ट कॉलम है, N लास्ट रो है. तो इस मैट्रिक्स का ऑर्डर क्या हुआ? M क्रॉस N, where these I, J, M, N are natural numbers. ये natural numbers होंगे, फ्रैक्शन में नहीं होंगे, नेगेटिव नहीं होंगे. ठीक है? These are natural numbers, or you can say they are positive integers, right? So note down this thing, then we'll proceed. Any doubt in this? Yeah. Okay. Now we have few examples. See example number 1. In example number 1, we see that there are two types of workers, men worker and women workers. And they are working in certain factories, factory 1, factory 2, and factory 3. So this information can be drawn in tabular form. Okay, this example 1 shows how this information can be drawn. If we represent the number of factories as rows, first factory, second factory, and third factory. So these are rows. So and we are representing men workers and women workers as column. So this information, when we write in the matrix form, it will be something like this. So in first factory there are 30 men workers, second factory there are 25 men workers, and like 27. First factory 25 women workers, 31 and 26. So what we have done, we have represented this information in the tabular form or in the matrix form. In rectangular tabular form, and the order of this matrix will be 3 by 2. The order will be 3 by 2. This information can also be written in another matrix B, which is something like this. If you write number of factories in columns and men workers and women workers in rows, so that matrix could be called 2 by 3 matrix. So same information can be written in two different ways. So these are this means this is the order written in the tabular form or matrix form, right? But the entry here, this information will be called which element? A to 1. A to 1 is this information. Okay, so it has a very specific placement, like you have done PNC. Combination means order. So we have to follow the order. We can't change the order once it is decided. So this element is called which element? A32. This element is A32. So every element is fixed. And how do we locate? First, we look at the which row, and then we see which column. So this number m cross n shows the order, or Aij shows the location. Aij shows the location. I means which row, and J means which column the element is placed. Is it clear? Now let's go forward. Now look at example number 2. Example number 2 says, hello Sairam.
Hello. Hello. Hello.
Okay. Now look at this example number 2. It says a matrix has 8 elements. Okay. A matrix has 8 elements. So how many different order of matrices can be formed? So very simple, you make the pair of factors. So 1 by 8 and another will be 8 by 1. You can write it 2 by 4 and 4 by 2. Is there any other pair possible for 8? No. So there are 4 possible order of matrix in which you have 8 elements that can be put into matrix. Right? Now next is example 3. Shall I clear the board now? Okay. Now the next is you are given one general information about the general element Aij. Look at the board. Aij is equal to half time modulus of I minus 3j and modulus close, right? And you have to construct she is not joining.
Hello, sir.
Hello, Sonia. How are you?
I'm good, sir. How are you?
I'm good. Okay, so have you revised what we learned that day?
Yes, sir. I got all the questions correct in the exercise except the two MCQs.
Okay, I'll just take up that. Wait, I'm just I have another student for the trial. So let me bring you on that. Okay, then I will continue. You can also revise it. can also see the class. Then your revision will be done, right?
Yes, sir.
Okay. So, this is example 3. Now you are given this information. Sanya, you can switch on your camera. I can't see you here. Sanya, are you listening?
Yes, sir. Can you see my camera?
You're not visible.
Hello?
No, you're not visible.
I've switched my camera on.
Just be there all that, right? So this example 3 says you have a matrix and this information is given about the elements. And you have to construct a 3x2 matrix. You have to construct a 3x2 matrix, right? So how will you write the elements? There are 3 rows and 2 columns, right? So this will be A11, A12, A21, A22, A23, A31, and A32. These are the order of the elements. Suppose you want to, you have to fill all the elements. So now if I decide about this one, what will be the A31? So how will I find it? A31 will be, you replace I with 3 and you replace J with 1. Okay, so how will you write? Half times I means 3 minus 3 times J. J will be 1, right? So it will be like this, half 3 minus 3, that will be 0. So half will be the answer. So at this place, you will write half. So now you have to construct the whole matrix like this. Is it clear? Sanya, I taught you the 3.1.
Yes, sir.
Did we do multiplication and addition of matrices?
Yes.
Okay. So have you understood the multiplication?
Yes, sir.
Okay. Yes, sir. Let me explain him the different type of matrices, then we'll come to know. Now, the next point is equality of matrices. Okay. Equality of matrices. So when do we say two matrices are equal? If we say matrix A is equal to matrix B. So first condition is their order should be equal. You cannot have two matrices equal unless their order is equal. Is it clear? Order means this is order equal to. So the order of two matrices should be equal. Yes, M and N should be equal. So and corresponding element should also be equal. Corresponding element should also be equal. For example, if I say A is equal to B and in A we have 1, 2, 3, 4, which is equal to another matrix which is A, B, C, D. What does it mean? A is equal to 1, B is equal to 2, C is equal to 3, and D is equal to 4. The order of both the matrices is 2 by 2. Is it clear? So this is how we decide upon the equality of matrices. Is this clear? Now you can do these examples. Now we talk about the types of matrices. You can do example 4 and 5 now. And I'm just discussing the various types of matrices. Thereafter, you will be capable of doing the exercise 3.1. Okay. So, what are the different types of matrices? The first type of matrices is a column matrix. Column matrix. What is column matrix? Column matrix is a matrix in which you have only one column and and you can have any number of rows. So this is column matrix. Then you have row matrix. What is row matrix? Which has only one row and you can have any number of columns. ठीक है? उसके बाद है you have square matrix. Square matrix is you have same number of rows as the columns. Okay, so we write it n cross n. So what do we call it? We call it a square matrix of order n. We don't say n cross n. The order will be n. n
cross n होता है.
Both are equal. जितने rows है उतनी ही columns है. तो हम इसको n cross n इसको बोलेंगे order n. Order n का मतलब है इसमें rows भी n है और columns भी n है. Column भी n है. तो ये हमारी हो गई स्क्वायर मैट्रिक्स. क्लियर? अच्छा, अब हम बात करते हैं स्क्वायर मैट्रिक्स की वैरायटीज. डिफरेंट टाइप्स ऑफ स्क्वायर मैट्रिक्स. तो हमारे पास है डायगोनल मैट्रिक्स. ओके, Sanya, are you clear about these different type of matrices?
Yes, sir.
Okay. So what do we mean by diagonal matrix? See, this is a square matrix. First condition is it has to be a square matrix. Okay. So if I'm writing this matrix, what will be the order of this matrix? Order 3. Because here I have mentioned 3 rows and 3 columns. So the order will be 3. There are 3 rows and 3 columns. So it has to be a square matrix. What is diagonal matrix? These elements are these 3 elements which I have encircled are diagonal elements. Okay. How do we define the diagonal elements? If Aij is a general element, right? And order is n, okay? And I is equal to j. Whenever I is equal to j, then the elements are called general diagonal elements. Okay? So here it is A11, A22, A33. So these are diagonal elements. So a diagonal matrix is the one in which non-diagonal elements are 0. In which non-diagonal elements are 0. Which are not diagonal. Non-diagonal elements are 0. That is called diagonal matrix. Is it clear? So in this, if we write certain numbers here, suppose 1, 2, 3. So this is a diagonal matrix. Okay. Now then we have another category called scalar matrix. Okay. So what is a scalar matrix? First of all, it has to be a square matrix. Then it has to be a diagonal matrix. But now what happens? In scalar matrix, all the diagonal elements are same. It can have a different element. But first of all non-diagonal elements are 0 and diagonal elements are same. They are scalar. They are equal. They are equal. These are diagonal matrix can have different diagonal elements, but in scalar matrix, the diagonal elements has to be same numbers. Okay. Then we have identity matrix. Identity matrix has a symbol called I. So this is identity matrix. Okay. How do we write identity matrix? In identity matrix, it is a square matrix. It is a diagonal matrix. It is a scalar matrix. But what number should we write? It should be 1. The diagonal elements are all 1. So this is identity matrix. Is it clear? Now we have zero matrix. Zero matrix can have any order. It can be column matrix, it can be row matrix, it can be square matrix, it can be rectangular matrix, any matrix. But the thing is, all the elements are 0. All elements are 0 and it is denoted by O. So these are various kinds of matrices we have. Okay, now you can try these questions at home and now we will move into the next topic. Okay, Sanya, now let's come to your doubts. In 3.1, You had which down question number 9 and 10?
Question number, yes, 9 and 10.
9 and 10. You can also see the Chirag. I'm taking up this question number 9 and 10 from exercise 3.1. Please do. Okay. Let's clear the board. So what does question number 9 says? Which of the given values of x and y make the following matrices equal? Now we are given two matrices. 3x plus 7, 5, y plus 1, 2 minus 3x. And we have another matrix 0, y minus 2, 8 and 4. We want certain values of x and certain values of y such that 2 becomes equal. We know the condition. The first condition is their order should be same. So, Sanya, is order same?
Yes, sir.
Order is same. If order is same, then corresponding elements must be equal. Right? So in this case, 3x plus 7 should be equal to 0. This implies 3x should be equal to negative 7. This implies x is equal to negative 7 by 3. Right? Now, if we look at another x, it is 2 minus 3x. It should be equal to what? Yes, Chirag. 2 minus 3x should be equal to what? Your name is Gaurav. Okay, sorry.
2 minus 3 should be equal to 3.
Yes, Sanya. 2 minus 3x should be equal to what?
2 minus 3x should be equal to 4.
Right, it should be equal to 4. This means 2 minus 4 should be equal to 3x. Minus 2 is equal to 3x. So this implies minus 2 by 3 is equal to x. How is it possible that x has two values? It is not possible that in the same equation x has two values. So we will opt for B option, not possible to find.
So I can't
Is it
see.
clear?
No, I can't understand this one. How is it not possible to find? Your video is frozen.
Just a minute. Maybe I have to send you another link. Wait.